So let's make a quick comparison of the two different types of titration curves that we looked at. The main difference between the two is that weak acids are involved in an equilibrium. And so many of these points on the titration curve are directly related to the Ka of the acid. This isn't true for a strong acid, strong base titration. Because the strong acids are considered to go all the way to the right, there really is no difference between the different strong acids. If I put in 1 mole of HCl, I get 1 mole of hydronium out. If I put in 1 mole of HBr, I get 1 mole of hydronium out. So more or less, these points on the titration curve are exactly the same, regardless of the type of strong acid that we use. So in a strong acid, strong base titration curve, the starting point is going to be the same regardless of which strong acid I use. And the same thing is true for the equivalence point. For a strong acid, strong base titration, when we reach the equivalence point, the pH is 7. It doesn't matter what strong acid I am using. That's not true when I use a weak acid, strong base titration curve. So the starting point, remember, was directly related to the Ka equilibrium, and so that was directly dependent on the actual Ka. So this starting pH is going to vary depending on the Ka of the acid. So different acids have different Kas. Same thing, the halfway point where the pH is equal to pKa, that's going to change also. And then remember that the pH of the equivalence point was directly related to the conjugate base, the Kb for the conjugate base, and so that's going to vary also depending on which acid we're looking at. So just in summary here, of the two, the initial pH of a strong acid, strong base titration curve is lower because it's not affected by the equilibrium. Here in the weak acid, we only had partial dissociation. So if I put in a certain amount of weak acid, only part of that dissociated into hydronium. I didn't have that with a strong acid. So the initial point, even though we started with the same concentration of strong acid and weak acid initially, the amount of hydronium came out was much more for the strong acid, strong base titration curve. So that's why the pH is lower. Here we see the buffer region that shows up when the pH is plus or minus 1 of the pKa of the weak acid. And one of the things that's kind of interesting with this is you have to remember with the equivalence point for a strong acid, strong base, you need to remember that the pH is 7. So if you were actually to do the calculations, you would get that there was no acid left over, that the concentration of hydronium is equal to 0. And remember, we discussed that that can't be true because we have the self-ionization equilibrium of water. So there has to be some concentration of hydronium. So even at neutralization, the pH is equal to 7. So that's the big difference between the two. Strong acid, strong base at equivalence point, pH is equal to 7. Doesn't really matter what strong acid or strong base I'm using. With the pH at the equivalence point of a weak acid, strong base, the pH is going to be larger than 7. So that's because we have a conjugate base around. The conjugate base is going to react with water and produce a slight amount of hydroxide. So the pH is typically going to be greater than 7 for a weak acid, strong base titration curve. So where the pH is going to be at depends on the Kb of the conjugate base. One of the things that's kind of interesting is after we get to the equivalence point, you can see that the curves are pretty much the same. So after we've used up all the acid, what we have left is strong base. And how we deal with it, the calculations after we reach the equivalence point are exactly the same. We just say how much base is left over. So it doesn't matter if we were starting with strong acid, strong base. After we reach the equivalence points, the calculations are exactly the same. And then one final note is you can see that as we get to the equivalence point, the pH rises very quickly. So that's true for both of them. And then just the difference is when does this occur? What pH does this occur at? But things tend to stay pretty leveled out until we get very close to the equivalence point, and then it shoots up very, very quickly. And it doesn't matter if it's a strong acid, strong base, or a weak acid, strong base titration curve.